Hello everyone, myself Dr. Santamay Kundu. I welcome you to this lecture of soft computing technique. This is the third lecture of module 3. So, till now we have covered module 1 and module 2. In module 3, we have studied fuzzy rules and fuzzy inference system. Basically, there are three types of fuzzy inference system we will study. We will first study Mamdani, then we will start Sugenos and Tsukamoto type of inferences. So first discuss Mamdani method of inference. Mamdani's method is the most commonly used in applications due to its simple structure of min-max operations. We will go through each one of these steps of the method with the help of examples. In Mamdani type systems, the antecedent part of each rule may be a simple statement or a compound statement using connective like and or etc. So you know if and then we'll take the minimum, if or then we'll take the maximum, and the subsequent part is represented by a fuzzy set. If the antecedent of the rule has only one part, membership value of the input in the corresponding fuzzy set gives the truth value of the rule. If antecedent of a rule has more than one part, that is more than one input, the fuzzy operator, mean operator, if the connective is and max operator if the connective is or, is applied for the membership values to obtain the truth value of the rule. So this truth value is then applied to the output fuzzy set. So a rule containing rules of the form R is if uh, the rule Ri, if x is ai and y is bi, that then z is ci. So what I am going to say that suppose there is rule R1, that R1 says that if x is a1 and y is b1, then z is c1. Similarly, rule R2 is that if x is a2, maybe and or, let it is or, and y is b2, then z is c2, and so on. There will be R2, so on, maybe Rn rule is there. So first we evaluate in the step 1, we will evaluate the antecedent for each rule. Okay, obtain the each rule conclusion like the R1 conclusion, R2 conclusion, then aggregate all conclusions, and then if we apply the defuzzification method, and last step is summary and conclusions. So we'll discuss all these steps one by one. So first to try to understand this rule 1, if x is rule R1, if x is a1 and y is b1, then z is c1. So here we'll get some value, then we'll try to understand this by this example. The rule is that if service is excellent or food is delicious, then there will be output value. So here it is or, connection is or, so we'll take the maximum value. Suppose the value of x is 3, that is the mu a1, value is 0.0, this food is 8, so that is the mu of 8 is 0.7, or is connected, so here we'll apply the or operations, we'll get 0.7 as the output. Then we'll apply here some set. Suppose this is another fuzzy set, so this value is 0.7, so we'll consider this part of the rule R1. Suppose this rule is R1, this is, suppose this rule is R1. So this is x, this is y, or is connection, so to the maximum value, then we'll get this is the C1. So try to understand these things here. Suppose here rule is that if x is, for this question the rule is that R1, that is this part is R1, this part is R1. So this first is R1. So here if x is A1, if x is A1 and y is B1, then z is C1. So and is there. So try to understand here that this is the value of x, so that is mu x. This is the value of y, so this is mu y. So here there is the operation is and, so we take the minimum value, so that is C1. Similarly for this R2, if x is A2 and y is B2, then z is C2. So here it is and, so we'll take the minimum value, so that is x, so that is mu x, so that is y, so this is the mu y. So you need to take the minimum value because there is connection is and, so take the minimum value, so that is C2. So next is you need to combine it C1 C2. After that we need to use defuzzification for and then conclusion. So step 1 is that evaluate each rule, so that is the each rule. So now go back to the steps. So evaluate each antecedent, then obtain each rule conclusion, that is and or, then aggregate all the conclusions. So and then defuzzification, then we need to get the comparison. Then we need to find the summary and conclusion. So here this is the step 1, each rule antecedent, then conclusion. Step 2 is that, step 3 is combine, and then defuzzification and conclusion. So let's try to understand this another example. So another example is that, first one is that, so we need to apply some 3 rules are there. If x is A1, rules is that if R1, if x is A1 and y is B1, y is B1, then z is C1. Then z is C1. So here the set is like that. So suppose this is the fuzzy set. A1, so that is x, this is the mu x, this is mu A1 x, and this is that B, so that fuzzy set is like that. So that is B1, and this is something like C1. So if x is A1, y is B1, then z is C1. Similarly, suppose here that x is A2, if R2 is that, if x is A2 and y is B2, then z is C2. So try to understand this set is A2, this is B2, and this is C2. So here x value, suppose x is the value of input is x, so the value of input is x, value of here the input of b, y is, this value is something like the value of y. So now here we take the value of x, so here the mu is 0.0, here mu is something 0. Suppose it is 0.1, so it is the and is there, so need to take the value of minimum value, so that is 0 here. Now try to understand that here if x is A2, so that part is the, suppose this value is 0.2, this value is suppose 0.1, so you take the minimum value, So the output of the R2 is the minimum value and is there. So this value is 0.1. So that is the output for C2. This is the 0 output for C1. Similarly, there will be other rule. So you will get C1. So output is C1 union C2 and so on. Suppose that is n rule, so you will get Cn. So ultimately you will get this type of picture, maybe, or depends on the other C1 C2. So here you need to find the defalsification value to get the exact output. So that is the rule, is basically the Mamdani rule. So try to understand another example. So here example is that the rule 1, that is R1, says that if service is poor or food is rancid, then tip is cheap. So R2 says that if R2 says that if service is good, then tip is average. And third one is that if the service is excellent or food is delicious, then tip is generous. So first to find the service 3, the input of this variable, service variable is 3, input of food variable is 8. So here the mu, this is the mu of the service is 4, that is the R1. So let it is A1, it is B1, it is A2, it is B2, it is A3, it is B3, it is C1, it is C2, it is C3. The rule says, Ri says that if X is Ai and Y is Bi, then Z is Ci. So here, then Z is Ci. So here A1, X means the service, okay, Y means the food. So input of service is 3. So here this is some value is there. So that is OR, so we'll take the maximum value. So that is very less, so this is the maximum value. So this is the output of C1. Similarly, this is service is good, so there is no part here, so directly it will go there. So that will be the output of the second rule. Third rule is OR, so we'll take the maximum value, so that is the minimum value, this is the maximum, so we'll take the maximum value, this. Now we need to union all these three, so that is the combined figure. So now from here we need to find the Krebs output by defalsification. Next we need to use defalsification to get conclusion, to get Krebs output. So these are the example of Mamdani. So I hope you have understood the Mamdani. Next class we will solve few example, numerical examples. So now try to understand the next one, which is the Sugenos type inference. That is basically the formula base. So here the rule is that if X is AI, Ri, if X is AI and Y is Bi, then Z is some formula. So it is like that. If R1 rule is that if X is A1 and or and it may be or, so for and we'll take the minimum, for or take the maximum, Y is B1, then Z is some formula. So that is like something like 3x plus 4y plus R2, like that, plus 10. So here we'll get the output Z1, and here we'll get some value that is called weight will come here. So if X is AI and Y is Pi, then Z is some formula like that, Pix plus, these are the all Krebs number, Pix plus Qyy plus Ri is implemented as shown some figure later on. We see it, the Krebs value computed corresponding to different rules are combined to form the final output value by computing the weighted average of the Krebs values. We need to find the weighted average. The weighted being the truth degree of the respective rule conditions. In Sugenos type inference directly leads to real Krebs values without defalsification. So in Sugenos there is no need to use the defalsifications. So this is the something rule is that, suppose here rule given as if X is that is rule R1. If x is A1, suppose it is or y is B1, then Z1 is P1x plus Q1y plus R1. Rule R2 is that if x is A2 and y is B2, then Z2 is P2x plus Q2y plus R2. So here, suppose this is the input x, here input is the y, so that is the mu A1, that is mu B1. So suppose it is OR, so we'll take the maximum value, so this value will got the value W1 and Z1 would be given by the formula. So suppose this is AND, so that value will W2, so we'll get this value Z2. Now apply the weighted average method. So that without using differentiation method, we directly get the Krebs output, which is Z1 Z equal to W1 Z1 plus W2 Z2 by W1 plus W2. W1 is the output of the each rules. If the rule is given as OR, we'll take the maximum value. If it is AND, we'll take the minimum value. Now the next is that Tsukamoto type inference method. So in Tsukamoto type method, the consequent part of each fuzzy rule is a fuzzy set with monotonic member function. If the antecedent of the rule has only one part, membership value of the input in the corresponding fuzzy set gives the truth value of the rule. If the antecedent of the rule has more than one part, then fuzzy operator, mean operator for AND, max operator for OR is applied for the membership value to obtain the truth value. So in Tsukamoto fuzzy sets, the output fuzzy sets, that is output fuzzy sets, which are C1, C2 and so on, put fuzzy sets with monotone, that is either increasing or decreasing, with monotone membership functions. So that membership functions either increasing or decreasing. Monotone output fuzzy sets C1, C2 and C1 are with monotone membership functions. So here this truth value is then applied to the output fuzzy set, and the Krebs value of the output having the membership value equal to the truth value of the rule is determined, that is either AND or. The Krebs value computed corresponding to different rules are combined to form the final output value by computing the weighted average of the Krebs values. The weighted average being the truth degree of the respective rule conditions. An example of Tsukamoto type is given, the rule is that if see in the figure. So here the rule is that if x is A1 and y is B1, then z is C1. So here this is the mu A1, this is the mu B1. So if it is minimum, then take W1. So this is W1 and the corresponding this value is Z1. So this value is Z1. This C1, C2 are monotone. That C1, C2 membership functions of C1, C2 are monotone. So what I am saying that this is rule R1. If x is A1 and y is B1, then z is C1. Rule R2 is that if x is A2 and y is B2, then z is C2. Note here that membership functions of C1 and C2 are monotone. So membership functions of C1 and C2 are either increasing or decreasing functions, either increasing or decreasing function. So that C1 membership function of C1 and C2 are either increasing or decreasing. So rule is that if X is A1 and Y is B1, then Z is C1. So here this is R1. So this is mu A1X. So if X is A2 in the rule R2, so this rule is mu A2X. This is mu B1Y. This is mu B2Y. Now rule is that and. So we take the minimum of these two, mu A1X and mu B1Y. Take the minimum value, so that is W1. So W1 is that minimum of mu A1X and mu B1Y. So that is W1. So now this is W1. So the value of Z1 such that mu C1 Z1 is W1. So need to find the value of Z1. Similarly, here it is also and. So take the minimum value of W2 is the minimum value of mu A2X mu B2Y. So Z2 is such a value, that value is either increasing or decreasing. So we'll get a Z2 for which mu C2 Z2 equal to W2. To net we will get Z2 and W2 here, Z1 is W and W1. So we take the weighted average. So this is the output value. So that is basically the Tsukamoto method. So in this class we have discussed three inference method. One is Mamdani, second is that Sugeno, and third one is that Tsukamoto. So these three inference method you have studied. So question is that with proper diagram, with proper example, question is that with proper example, try to understand these methods graphically. So these are the references of today's class. Thank you. Have a nice day.